Hi, and welcome to this lecture on lists. In this lecture, we are going to learn about what lists are, creating lists, accessing, slicing, ordering, updating, and duplicating lists, along with the built-in methods and some common errors that you might come across. Okay, let's open up the script editor and get started. All right, let's go straight down to, I'm going to go for panel today, 5 up, script editor. Okay, let's remove that, make sure our text is big. Okay, and then be sure and make sure that you show line numbers in errors and show stack trace, okay? Just for if you do make an error, so it gives you a bit more of a readout. Okay, so let's start with our first section. What are lists? Okay, lists are used to store multiple items and multiple data types in a single variable. Okay, lists are one of 4 built-in data types in Python that is used to store collections of data. The other 3 are tuples, sets, and dictionaries, and they all have different qualities and scope. All right, so the key features are that these are changeable. You can add, remove items, and they also allow duplicates. Okay, now those are some quite important features that you should probably, if you are writing notes, and I highly recommend you do, you should probably write those down. Okay, at the very top, what the can and can'ts are of this type. Okay. All right, so let's get started. Creating lists. Okay. Lists are just created, simple as we showed within the data types with square brackets. That is a list. Simple. Okay. Go with type. Check it. Class list. Okay, it's a type of a list. Okay. All right, let's apply this to something. Okay, sorry, let's get set up. All right, so this is our list. Okay. All right, we've got our square brackets. We've got our string. Okay, Nick. We've got a comma. And then we've got a space, mainly for readability. Okay, we've got John and Mike. So these are 3 names that we've got within this list. Okay, and then we can print this variable. If I actually copy it and say, okay, print this list. Okay, and it literally gives us everything with the square brackets, Nick, John, and Mike. Okay, so you'll see that this list is ordered. Okay, but remember it can be changed and it can allow for duplicate values. So we can also put in Nick again, and we will still get Nick. It's unlike a set that I've shown you within data types, it cannot, okay, have any duplicates. All right, we'll go back though. So the list function also creates list objects that you can pass a tuple, pass to a tuple or a dictionary, or create a list from. So let's have a little look at what I mean by that. So if we've got this as a list, okay, we can actually go list. So we're actually calling our class object list here, and we are passing it these items. Okay, now if we try it like this, we're going to get a type error because this list is actually being passed, okay, 3 items, but it expected 1. So we need to pass it a tuple of these 3 items rather than just 3 items that we can expect to be in a list. So now you'll see we've got our list functionality, which is actually taking this tuple or this tuple. Sorry, I would never really know how to say that, but I go with tuple generally because I'm English, but then Americans normally say tuple. Oh, the agonies. Okay, so list, simple. All right, we're now just going to essentially transfer this tuple into a list, simple. Okay, but we can also pass it key value pairs. So we could also do curly brackets. We could go Nick 1, John 2, Mike 3. Okay, and what will this do? Well, it's accepted it. Okay, it's accepted our dictionary. What's it going to give us? It's going to give us a list with Nick, John, and Mike, because lists don't accept key value pairs. They just accept a single array of items. Okay. Now that's important to remember. So if you ever pass a dictionary into a list type, this is what will happen. So, all right, that is the easiest way to explain creating lists. You can either use the list functionality, which I do sometimes if just for readability, again, to kind of let people know if I'm creating something empty here, which I'm going to be then changing later on. I might use a list just so that people glance at it, because obviously some people will again they'll look at text like this. I mean, I do it sometimes if I'm trying to look at or comprehend a much bigger script, but obviously then it's coming a little bit harder to understand what those little symbols there are. Okay, but if we write list, I'm giving a little bit easier, but again, just as fine, and I don't really think there's any problem with doing it that way either, because yeah, it's just as readable. All right. Okay, cool. Let's move on. So that's the first two ways of creating lists. Okay, we can also use a syntax called list comprehension. So when you want to create a list, this is not an easy one to understand before we cover loops later in these tutorials, but it's kind of a chicken and egg situation with these two. So sorry about this, but I'll do my best to break this down simply. Okay, so if we start with this loop again, and we want every item, say, with an O in them, then we can write a loop to check through these. Okay, so let's create a list comprehension. So what are we going to go for? So let's just go back a little bit. So go for our square brackets. There we go. Okay, so we've got this as a list, and now we're going to create another variable with names with O. Okay, we're going to, again, just create an empty list. This is going to be a placeholder for the moment. Okay, so I should probably clean all that out. Let's have a little look. All right, so we're going to create a little loop, and we're going to say for name within a variable list, this is a list. So now within this for loop, what we're doing is, you remember, we are cycling through everything within this object here, and we're assigning it to the variable name. So for the variable within this list, okay, and then we're going to just, for example, let's print out name. What's going to happen here? So we're cycling through and we're printing Nick, printing John, printing Mike. Okay, very straightforward. Okay. So now we can do, and this is just a basic for loop. Okay, sorry, this isn't the list comprehension yet. We're going to get to that. This is just a simple for loop to explain what we're going to do and how. So we're now going to go if O in name. So we're looking at within the string name. We're cycling through every item in this list, each item with that is a string, and we know it is. And lower. Okay. We are going to then add that to this item, to our new list. Okay, names with O. Okay, we'll go through these functions later, but we're going to append to this list and add to it the name. Okay, so append is a functionality of lists that allows you to add items to them. So names with O now equals just John. Okay, so we've got our list with all three, got our empty list we started with, and then we've cycled through our list and we've said if O is within name dot lower, because we've made it lowercase, just to check if somebody had Oliver as a name. You might want to make sure you caught that because it has O within that name. Okay. Then if the item has O within it, then add that to the list names with O. So, for example, you might want to catch double barrel names in the future, hyphens or something if you're doing work with data. But this is the basic way you do that. Okay, so simple. But okay, let's move on now to the list comprehension we were talking about. If we open some square brackets, we can add a list comprehension that can do kind of most of this in one line of code. And most of the time, I'd say this was more readable, but you know, you can go a little bit crazy with these. So just try to make sure that, again, readability counts. You look at this, try and look at this with your eyes in 5 years' time, or your eyes with someone who maybe hasn't seen your code before. All right. So we'll do this exact same thing here. Let's add another name to this actually as well, just to make Make it a bit more interesting. Okay, we're going to go names with O. We're going to start moving all of this for loop into this one line. We're going to go name for name in, this is a list. Okay, so now this is going to return us each item within here. So we've got our, this is a list with all of our names in it. If we execute, we see all of our names, got names with an O, and this is going to literally cycle through this information. And this is going to, and doing exactly what we're doing here. We are assigning every item to name within this list, and we're going name. And this is though the returned item right here, but we are cycling through it and we're going name for name within this list. Okay. And you'll see if we just run it right now, we literally just get returned our list because we've cycled through each one and we have added it. You'll see with these square brackets to a list in this list comprehension. But we can also add conditions to this. So after our list variable, we can go if name. We can actually add that. You can just copy and paste all of that. So if O in name.lower. Okay. And now we can reassign to this variable. We will just get John. Okay. Because we have cycled through each item within the list. And then we have our condition with our expression O in the name. Okay. So we've got our list with a condition built in. I'd say that was quite nice and readable. Generally, it's just nicer being on one line. And it's kind of obvious that it's a list comprehension because you get, again, highlighting in most IDEs and in Maya that's kind of showing us all of these items within the loop here. And so that's our list comprehension. That's the third way of creating lists, okay? It's nice and simple. So let's go back and have a quick look and break that down. So like we said, returned for returned in the iterable item, which is the list. And we can also, we don't have to, but you then add a condition. All right, nice and easy. So we could do the exact same thing. We could just change that for I. We could reassign. So this should return us Nick and Mike. Yep, Nick and Mike, we both got I's in. Easy, simple. Okay, we could also check this. Let's put a print in and actually just get the print output coming. And then we could also, and let's actually, again, abbreviate this just to make it a bit easier for us and a bit shorter. And our lines, again, I wouldn't suggest doing this maybe all the time, but it might be a little bit easier just to make the line a little bit shorter and exact, and then it kind of accentuate what we're actually looking at here, which this is a list, okay? All right, so we can also add other conditions in here and other expressions within the condition. So we could also go, let's say, is the length of the name higher than 3? So we'll go length of n higher than 3. Yeah, okay, there you go. Ben is obviously just 3, so that's not higher. Okay, it is the exact same as 3, so we could go is higher than or equal to, so that would include Ben now. But if we just go higher then it's got to be 4 or above. Okay, we could say if the name is something, so let's say if the name equal to Nick, and obviously this is going to be case dependent, so if we put lower n there, it would not return my name. But you see, yeah, I'll return Nick, so I'm checking explicitly if it is Nick, okay, within that expression. Okay, we can check if items are not Nick, so is this item not me, okay, or my name? And yeah, all of these names are not Nick, okay, nice and easy. All right, so that's for checking for things or if not, and we are now going to just move on to kind of different data types that we've learned about in the iterator, how this can be used. So we've given ourselves an iterable object here. Let's have another little look, and we'll go for our list. Okay. We're going to do another list comprehension, and we're going to go x for x in, let's go for a range 10. So, okay, this is our iterator here. It's going to give us a list, essentially, well, it's going to give us a generator that gives us numbers up to 10. And look, it gives us 0, because again, 0 is the start point, up to 9. Okay, we could change this around. We could be a bit cheeky and go +1. And then look, we do get from 0 to 10. Okay, so this is another cool thing with list comprehensions. You can actually add functionality at the beginning and the end. So you can add the conditions at the end, but you can also change things at the beginning. Okay, this is what's returned in this section here, and it can be anything. Okay, you've got to remember that. So, okay, we can say return everything within our range if x is above. No, that obviously won't print anything. So let's just put that back to there. We go x. Okay. So we're now just going to print everything above 5, which is 6, 7, 8, 9. Okay. What else should we go for? Let's copy that. Okay, and actually we'll get our list back of names. Give another example with those. Okay, so we'll cycle through our list of names again. And we will remove our if condition or if statement. And we will, okay, just print out everything from here. So got our new variable here, and that is also now being assigned Nick, John, Mike, and Ben. But what we can do, like I said, you can return everything here. You can return anything you want. Hello. So now what we're going to get? We're going to get hello is essentially being input for every item in this list. Okay. Doesn't have to be a string. Could be a 1. Okay. Because we are cycling through this list. So it's giving us 4 cycles that we're running through. But this is what we're outputting here. So we could also, I don't know, we won't go into dictionary outputs yet, but you can literally put any type in here and it will print that for everything. Whoops. There we go. True. So we're going through our list, we're assigning, we're just giving the feedback on the returned item being true. Okay, so for true, for x in x. Okay, simple. So for a returned item within x in this list. Okay, brilliant. Okay, let's move on now. Let's go accessing. We've just covered creating. Okay, list items are indexed kind of like strings. The first item is indexed to 0. The second item has an index of 1, and so on and so on. So let's bring back our list of myself, my couple of friends. And we are going to print this list out with the index 1. Sorry, the index of 0, or the first place within the list. Okay, it's me. It's Nick. Okay, we do that as 1. It's John. 2. It's Mike. And 3. Well, this is going to give us an index error. Yep. There we go, because there is no third item here. If we had Ben back in there, then hey, Ben's in there, okay? But you can't index, you can't look for items that don't exist, okay? If you call them out explicitly like this, then it will return you an error, okay? You can also do negative indexing, okay? That's also supported, so putting a minus, counting from the back, so 0. So remember, 0, 1, 2, 3. But if we go in negative indexing, we've got 0, go back to the beginning, go -1, -2, -3. So let's go with John is the -3rd, so -1, -2, -3. And we get to John. Okay, -1. Okay, last person, Ben. Easy, simple as that. Okay, just like strings. Okay, negative indexing is exactly the same. So let's write a little if statement for these. So let's go with if let's say if John is in this list, or this is a list, and we will print give the user some feedback, yes. We'll do single quotation marks so we can give the information John is in this list. Okay. So if not, we'll go else. We'll give the information back. No, John is not in this list. Okay, now, what do you think we're going to get out of this? Okay. No, John is not in this list. So why do you think that is? Why is this John not being married up? Well, you remember strings are case sensitive, okay? This data is not the same as this data over here, okay? Simple as that, okay? What we would need to do is to go uppercase and then go, yes, John is in this list, okay? It is simple as that. You've got to remember case sensitivity, okay? All right, awesome. Okay, so slicing. And again, same as strings. Okay, we can slice using a colon. So let's get everything set up. Okay, and that carries, so using the colon, it carries out slicing. So we can index using a single integer, or now we can add, okay, we can use two integers, and we can use the colon. Okay, by default, you've got the beginning and the end, okay, in each position. So if we did position 3 to 6, now obviously there aren't 6 items in here. What's going to happen? We just get Ben, okay? Ben is within that parameter. It's not going to error if there aren't any items, unlike it would if you were indexing, okay? But when you're slicing, you can just look within any area and it'll return all of the items within that area of the search. So 0, 1, 2, 3, and then it'll find that and anything else after it, okay? So if we made that 4, okay, you're going to get nothing, okay? Simple as that, okay? It's worth noting that it won't raise an error if your index or if your slice, okay, don't have any items within the index, but it won't raise you an error, but it will just return you nothing, okay? All right, so just remember, slicing is done from default from the 0. Okay, so if you leave that empty, it'll be 0. If you put that as 3, it'll just return you the first 3 items, okay? You can also remember that we do negative indexing. So we can go to -2 and the third item, and then we'll just get Mike. So we're counting back. We're going to start here at -1, 2, but we're also going to count from the third. So 0, so 1, 2, 3. Sorry, we're using indexes here. So we start from 1. So 1, 2, 3. Okay. Or sorry, the third position. So 0, 1, 2, and then the third, Mike. Okay. All right. Simple as that. Okay, and then you've got to also remember that you can change the ordering with these. Okay, so that's slicing. I think we've gone into enough information on that. Okay, we've got negative slicing, okay, which can be done from both positions. So we can go to -1 from the back, and then from the end, and then from -2 at the start. So, all right, nice and easy. Okay, either count from the beginning or count from the end. But okay, let's now move on and look at ordering, okay? So section 5. Sorry, so that was slicing we just went through there, okay? But we can also iterate through and control this iteration in lists by using 2 colons, as again with strings, with the first 2 positions being the start and end indexes, and the last position being the steps or the directions of the index. The default is 1, okay, for the last position, which will just cycle through every item iteratively as normal. Okay, 1, 2, 3, 4, and so on. All right, so let's have a look at our list now. All right, so these are the defaults. So 0, okay, end item -1, okay, and 1. So if we typed in -1 here, we get the whole list backwards, okay? Ben, Mike, John, Nick, okay? Simple as that. We type in 2. We get every second item from the beginning, okay? So we go Nick, Mike, okay? We're missing out every other item, okay? Do that with 3. Just get Nick and Ben, so get 1, okay? And then 1, 2, 3, Ben, okay? All right, let's try and sort this list, okay? Try and order this list by sorting. Let's have a look. So this is quite powerful, which we're going to go into again in a bit more detail in some of the next lectures when we look at how to work. Ooh, okay, sort. What have we done here? Okay, so sorry, what we're doing here is we're actually trying to run a function which doesn't return anything within a print. So, okay, this is a function you run outside of a print, and what it does is sort your list. So let's have a look at our list. So Nick, John, Mike, and Ben, here we go. And let's run this function to sort. Now the default is for this to sort alphabetically. And now if we look, we've got Ben, John, Mike, Nick. So everything is going alphabetically, okay, and iteratively through the word. So if we had Ben and Benny, okay, Ben would come first, okay? All right. So let's have a little look and do this a bit differently again. Let's set the reverse as true. Okay, so default is false, obviously, but now we're going to tell this to actually reverse the list. And we'll get the print going as well, so we shouldn't have that sort in there, but let's go print. And now we get Nick, Mike, John, Ben. Okay, this has gone reverse. This has reversed the list alphabetically. Okay, but we can also customize the sort functionality using a keyword argument key. Okay, now this is very powerful, and I'm assuming you will use this quite a bit. Okay, it's very quick and it's very useful. So let's sort this by, let's add something in here. Let's go Ben, John. Let's put lowercase. Let's say we wanted to sort by lower. Okay, so we're not going to reverse this anymore. We're going to type in key equals, type in the string type, and lower. So this is a functionality. We're not going to call the functionality with the curly brackets because we're just giving the base functionality to it. This is our keyword argument. This is our string type. So we're going to say for a string, make that string lower. So it's a string method. We're passing it a method of string, which we want it to run and sort our list out by. So let's reinitiate our list. Okay, it is Nick, John, Mike, and Ben. 2 lowercase names starting here. Now let's sort these. Okay, what this does, it puts Ben and John at the beginning in alphabetical order. So Ben is first, and then it goes for the end. It goes for Mike and Nick alphabetically again. Okay, so that is the preference that we've put in for the check of that list. Okay, we can also sort by the length of the item, and we can use the lambda function, which again we're going to go into later. Okay, to pass the length of the items to and check it like that. Okay, so we'll be covering lambda functions later on in this series of lectures, so don't worry if these look a little bit confusing. To briefly state, it's just a one-line functionality. Okay, so it's very, very useful, very powerful. So let's get our key, and we are going to go with let's go with, so we've got, let's make it, oh, we've got too many 4 over here, and we say we'll go with Jonathan. We'll go with Mikhail, and we'll go with Stephen. Okay, cool. So we've got some different lengths there. Okay, useful. Now we're going to go with the key. We're going to type in lambda, which again, it's a one-line function. We're going to pass that lambda a variable of x, which again is anything we pass to it. And we're going to tell it to look at x. Okay, sorry, the length of x, the items that are being keyed. So within this key, we are passing it our list, and for each item, it's going to iterate through them, check their length, and then it's going to pass them back through to be sorted. Okay, so just as we did string lower functionality earlier, it returned us the functionality of string, which was lower. We're now returning ourselves a functionality of a lambda, which is our own created functionality, so it won't be as readable essentially. Okay, but let's see what happens with this. So yeah, we've got, I think, 4. We've got essentially the lengths of everything that have been ordered here. So we've got, what is it, 4, 6, 7, 8. I think the order, the lengths here. Okay, nice. Okay, 4, 6, 7, 8. Okay, that's the order it's kind of put them in. All right, it's ordered them in length. Okay, it's brilliant. That's very powerful. You're going to use this a lot, trust me. They're very powerful if you're looking through items within, let's say a recent example. So I'm looking through an avatar, essentially recently created for a game rig. I want to cycle through and I want to clean up the joint orients within them. So what I do is I cycle through the full name of all the joints, making sure that I'm gathering the length of the string and counting the pipes within the string. This allows me to know that I am taking all of the items that have the most pipes first, removing them, cleaning them, putting them back. Okay, because obviously I want to start at the end of the hierarchy, not at the beginning, and then move backwards through the hierarchy. So that's a nice, easy way to do that. That's a little bit of an example of how I've used this in my, even probably this week actually at work. Okay, so let's move on to updating our lists. Okay, let's clean out our output window. So unlike strings, lists are mutable, meaning that we can select an item at a specific index and set it to mean something different. So let's bring in our list again. So Nick, Jonathan, Michael, Stephen, Bill. Okay. And okay, let's get our list. We're going to go for the first index within our list. Okay, and we're actually going to state that to being the shorter version of that name. So got this as a list. And then we have got list index item 1, John. So now what has this done to our list? There we go. See, it's updated it. Because it's mutable, we can change it. And we have updated the name Jonathan to John. Maybe that's what he preferred. Okay, we don't know. Okay, you can change a range of items as well. So let's put this back to being Jonathan. Let's initiate. Okay, what we can do is we can say, let's change items 1 to 3. Encapsulate these into a list. Change them to James and Anthony. Let's actually print this and make it look easier. I can just select all and print, much easier. Okay, so now what have we done? Okay, great. We've changed out Jonathan, okay, and Michael, and we've switched them out for James and Anthony. Okay, that's quite cool. I mean, that is literally just input that information and updated our list based on the information we've given it. Okay, on these indexes between 1 and 3. Okay, you could add more items. Okay, so what we could do is we could put Jane or Jan. Let's go. And look, it adds another one. It doesn't have to be the same length because this is where we're telling it. We're telling it to take these items, okay, update them to whatever we pass here. So it can be 1. It could be 5. It could be 1,000. It could be anything you want. Look, we've shortened it with just James. Okay, simple. Adding to a list, as we showed earlier, can be done with append. So we can also go append James. Okay, so simple. We've added James to the end of the list here. Okay. All right. Now we can also do this with the extend. Okay. Ability here. So if we extend our list, what you might want to do is you might want to have these names within the original list so we can essentially extend them. So let's have a look and see what our output is here. So appending always adds an item to the end of the list, just so you know there. So now let's extend. Let's see what happens if we just leave this actually as is. What happens here? Okay, so James has extended the list, but it's actually taken this, and what it's looked for is a list input. And so it's actually put each one of these items in individually. Okay, so if we want James whole, we actually have to pass this a list. You see, we get James as a whole. Okay, so we've extended the name with James. And so what this is doing or allowing us to do is to, again, extend the list out with multiple items. There we go. So again, we're extending the end of the list here. Okay, so append adds to the end of the list. But extend allows you to use a list to extend the list with another list. So you could even just pass this another list variable. But let's see if we did the same for append. The append actually, because we've actually added a list, append has added a list. It adds whatever you add. It appends, it adds whatever items to the end of this list. Okay, 1, 2, 3. but extending will not do that same functionality. This actually don't think will work. No, it's because int is not iterable in that same way. That is actually just a number. Okay, this would need to be encapsulated within a list. Okay, because we are extending this with the type of list, okay, or anything that is iterable. Okay, let's look at another way of extending the list. So, all right, we could also go plus equals. So what we're going to get here is just essentially an extended list again, using the plus equal sign. So another quick way of extending a list, nice and easily. Okay, it's not to make, remember this is not going to add, this is not appending, it's not the same as extending, because we'll just fail. If we use a single item, this is what's going to happen. Actually, no, that would actually add the tuple as far as I understand it, or it should. Yes, there we go. So that is an iterable type. This will give you a tuple because we've separated these items. Again, this is a bit further on where we need to be at the minute, but this has created a tuple. Even though these items aren't encapsulated, this is a tuple because we've said within this one line in Python, execute this and look at this. And this is saying, oh, you've got these items separated by a comma. Okay, so these are an iterable item. Okay, we have a tuple. But let's say we extend this list with just James, like we showed earlier. James is now going to be looked at as an iterable, and it's going to be added to the list in separate characters. Okay, so inserting into a list is again very useful method. Okay, let's say we needed to insert James between Jonathan and Michael. Let's say these guys are getting a little bit rowdy. All right, let's do this. Oh, actually, sorry, I missed out quite a key bit of information. We need to put the index in, so let's put an index. Okay, there we go. Add this space, so 0, 1, 2. James has been inserted. Okay, nice and easy. We can do Rob. Let's see what happens if we do -1. Okay, so we're at 0 here. Okay, this is 0. And then we've gone to -1 and we've inserted Rob. Okay, so you got to look at the insertion points as being from 0, where we are at the beginning of the list or behind the first indexed item. Okay, unpacking in Python, or unpacking is a Python methodology that allows us to extract a list or a tuple of known length into a variable. So this is very, again, useful for readability. Let's have a look. So we've got this up here. But let's shorten this so I don't have to write too much because you'll understand quite quickly what we're doing. Unpacking, you'll use this a lot again. Like I said, readability. So let's go for friend 1. Let's actually just put an underscore in there for readability again. So now, if we know 100% that this list is going to have just 3 people in it, 3 items in it, then we can unpack it here. Okay. Now, oh, actually, I've reassigned that. Sorry. Let's put this to new list. Oh no, sorry. What am I doing? I'm unpacking. Oh, sorry. Long day. There we go. Okay, so now our new variables here are friend 1. Which is Nick, okay, it's a string, Jonathan, okay, and Michael. So these string items have basically been unpacked and just put into these. There's no remnants now of the list anywhere here, okay. These are 3 new variables created from this list, okay. You can also do little things like if you know you're going to have a lot, which again, you need to be readable, you can encapsulate these. You can open them up a little bit so you can import, you can indent them. Okay, I have them on one line. Boy, but you do need to have the comma separating them. Okay, if you don't have the comma separating them, yeah, it won't know what to do. This will be a syntax error. Okay, because you need that comma. Okay, and look, we've got friend 1, Nick, friend 2, friend 3. Simple. Okay, that's called unpacking. right? Let's have a look at duplicating and copying. Let's clear our output window, duplicating and copying. So you cannot duplicate a list simply by typing list2 equals list1, for example. So list1 equals list2, the other way around. So, because this will only be a reference, essentially list1 will only be a reference to list2. So any changes you make in list1 will automatically show in list2. This might have its use in some places, but generally I'm assuming you'll want a clean copy, okay? So one way to give ourselves a clean copy is to just explicitly state, okay, let's go back to our list we had earlier, that you want, okay, say list1 copy to be a copy. So you go copy, okay, this copy built-in method of this list. Okay, simple. So this is now not a reference, and any changes we do to it will only be within this variable. They will not be pushed back to. So if I appended 5 items to this, they would not show here. But if we just went simply, okay, this is this list, any changes I make to the copy will show up in the original. So that's something to make sure you're aware of. Okay, another way, which I actually kind of prefer, depending on the situation, just for my scripts, it's just to put a list. Okay, you can also, this is creating a new list with the iterable with inside it. Okay, that will not again reference the original. All right, nice and simple. Okay, let's clean our output window, built-in methods. Okay, let's bring our list back of the boys. Sorry, this does seem very sexist now I'm looking at it. Let's do some, let's add some ladies into it, because otherwise it just feels horrifically sexist. Let's go with Mika. Okay. Mika could be a, I should do know a male and a female called Mika. Okay, I suppose you've got Mika Häkkinen, haven't you? The Finnish Formula One. For anyone that's interested in that, I literally am not into Formula One. But I worked on the Toon series about 10, 11 years ago. So that had all of this kind of Formula One stuff. So it was a cartoon made for Formula One for McLaren, just to kind of try and get it to a younger audience, essentially. That is the tragic knowledge link for me. Okay, so returns the length of a list. Let's have a little look. These built-in kind of methodology. So length we've already kind of covered with strings, but okay, this returns. Okay, the length of the list. So let's give ourselves a print, actually, otherwise we're not going to get the output. So it's 5. Okay, this isn't counting any individual one. It's counting the length of the entire list. So 1, 2, 3, 4, 5. Okay, not the indexes, the length. So the standard length, okay, of the list. Okay, let's return ourselves the max of the list. Okay, so alphabetically, the last string or the highest number within this item. So Steph, okay? All right, so we've gone for alphabetically, the last person within this, okay? That is where we're looking here. So within a string, okay, it'll always give you the alphabetically highest iterated item, okay? Within a list of numbers, it'll give you the highest number. So let's do a list of numbers. So we got load of numbers. Let's go for max numbers. Oh, I've got to actually assign numbers, haven't I? Here we go. So I've got 452 right there. Okay, that's the highest one. So nice built-in functionality there. We've got min as well. Excuse me. Oh, terrible manners. Okay. And we have got 1. So that's the lowest. Okay, obviously it goes back into minuses. All right, we've looked at the functionality append. Which open brackets. Okay, we can just literally do dot append. Okay, adds on any item to the end. Okay, we could have also looked at extend, which obviously again takes a list item or an iterator or an iterable item. Okay. Okay, we've let's have a look at clear. So this is a list, clear. It's pretty obvious what I think this will do, but what do you think it'll do? Yeah, it's cleared our list. Literally like a standard clear. Here we go, cleared our list. Okay, copy we've had a look at as well. Copy will give us a copy of our list, not the exact list and not a reference. Okay. We can also do a count on our list. How many items are in there? So like the length functionality. Oh, my mistake. I am using this completely incorrectly. My mistake. Oh, what am I doing? Sorry. Completely misused that. I've thought. So we want to count an item within the list, of course. Yeah, I'm sorry. Here we go. There we go. Nick. There's one Nick within this. Okay, let's have a look back. Let's bring our numbers back up. So we can actually now count a little bit more usefully, maybe within a list of iterators, or within a list of numbers, sorry. How many ones are there? Okay, what's it doing here? That's interesting. Oh, of course, okay. Okay, I've got to put numbers there. Sorry, I was actually checking for ones within. This is a list state variable. Okay. See, easy to make silly mistakes. Okay, that's what you got to remember. But you'll just get an eye for what you've done. Okay, so we've got one in there. Okay, how many twos have we got in there? 4. Okay, very useful for specific scenarios. Okay, so let's have a look at index. Okay, index similar. We can have a look at what the index is of the first 2. So the 5th one is the first 2. So we got 0, 1, 2, 3, 4, 5. There's our first 2 at index 5 as stated. Okay, this is really useful if you're searching for something you need to pop or get rid of it. We can then go pop 5. You can also assign that, and it will return just that item. So we can go number popped. And then we go, I've actually done that twice. Okay, so then we go numbers, and you'll see 2 has been popped. It's been removed. But number popped as a result of, it's given us the 5 that was there. So it's given us that 5, it's taken it out. So let's say you get a list of items passed by a user and you want to use driver-driven mentality. If they select one control and they want to assign that control shape to all the other controls that are selected, you can take that list or gather the list or gather the item selected, and you can pop the first item saying that's the driver. Okay, and then you can use the rest and iterate through it and assign that shape to it. So there's a little bit of use that you can use there. We can also insert using a very similar mentality there. So we can insert, picking the index, and then whatever the item is within the list, Rob, and then we can print numbers. So now, oh, I've done that wrong, haven't I? Here we go. Oh, of course it has, yeah. Sorry, highlighting is a bit of a pain in the backside sometimes. Let's remove, sorry, I think I've got too many things here. I'm sorry if that's been confusing. So we've now got our numbers list. We are inserting at the index 0.5. We're going to insert Rob. So there you go. Within our list now we have inserted Rob. There we go. But we can also, in this list, remove Rob. So if we actually did that, we want to say remove something later on. If we have Rob in that, if we had Rob in there, we can just remove Rob. Okay, so let's test this. Let's do Rob. There you go. Removed it. So numbers is in there. Okay, with Rob in the middle. We say actually we want anything that's a string and not a number in there removed. So we go numbers, remove Rob. Okay, great. Okay, simple. We can reverse the list. So you can either do it as we showed earlier. You can either write reverse. Remove Rob. Okay. And you see now we're going back through the list, okay? 2, 4, 3, 2, 2, 1. So 2, 4, 3, 2, 2, 1. There we go, going back through this. So we can reverse. And this will be a permanent way of setting reverse to that list. This has affected change on this list, okay? Whereas where we are essentially slicing, indexing, and iterating here, if we go -1 here, let's go with a big number of 300 to make it even more obvious. So we print all numbers now. See, 300 is still in the middle. We've actually not reversed it here because we haven't actually changed this numbers list. What we've done is we've just changed this list right here that we're calling. So we could assign this list to another variable, okay, because we're iterating through it. So we could do new list equals, okay, and do an underscore just for consistency at the moment. Okay, and we could do new list equals numbers, reversed. And you'll see we're now going from the back of the numbers, so from 300. But if you wanted to do that straight away to numbers, you could just go numbers.reverse. Okay. And then as we looked at earlier, we've also got sort. So we could do sort, which again will permanently sort and append that list. Sorry, I didn't use the word append in this context, but it will change this list permanently. So if we print out sort, we see we've now sorted this list in size order. Okay, easy. So very nice and easy. But you can also use that and reverse. Go true. And you'll see we go from the other side. Easy. Okay, so those are all built-in, all the built-in functionalities and methods of lists. Okay, very powerful, very useful. Okay, they are brilliant things and you will be using them a lot. So don't worry if this was daunting because you will be going through all these functionalities a lot. Okay, but let's try and think of some common errors that we might get with these lists. Okay, so you might append the wrong item in a list. Okay, that's probably the one that I would say was the most consistent that I see. Okay, within common errors. Okay, off the top of my head. All right, it's very easy to, like we did there, we removed Rob because obviously we stated exactly what Rob was. But you might want to first go through a list. And you might want to say, okay, you might want to cycle through the list and you might want to get the index of, say, 2. Because, okay, sorry, this hasn't got, 2 is not on the list. Obviously, we've done the list of strings there. So we want to do numbers. Okay, because the numbers, and even spell it right, that might help as well. Python's very pernickety about things like this. Okay, so we do numbers. Okay, we've got a numbers list. We want to get the index of 2. So we've got the first index is 10. And we've got to make sure that we use that. We've got to return ourselves that. We shouldn't ever be trying to guess these things. We should always try to be write the code to make sure that we are always dynamically getting the items that we need to maybe pop, remove, clear, or delete from the list. So item to pop. So let's say item to pop would be, okay, there. So now we have that stored, and then you could use in the next line. So if you wanted to, so you wanted to pop and remove that item, you could then go item to pop. Okay, so that would be the most common error I think I see. Okay, and again, probably also mixing up functionality with tuples and sets. Okay, we're going to go through those next, but it's very easy to confuse the functionality with them. So make sure you're taking notes. And you come back to these notes, or even then just make sure you go to Google and check the documentation within Python syntax and within lists. Okay, and even if not, Stack Overflow, you're probably there. I mean, I can guarantee you somebody will have made the error that you will have made. That is why Python is one of the best languages, because yeah, everyone makes errors and everyone will make an error and asks for help. So you can have a quick look and somebody will be telling you how to fix it. Okay, nice one. Well done. Those were very tough concepts to first jump onto, but well done. And thank you for sticking with me on it. So in this video, we have learnt about what are lists, creating lists, accessing them, slicing, ordering, updating, duplicating them, built-in methods, and some common errors that are also associated with lists. Okay, thank you so much, and I'll see you in the next video.